today's session, I will talk about maths difficult problems asked in JEE Main. So you can see there are too many things they have given the question. Like I like to give you one idea, and then it should be symmetric also. That means only 3 elements to be chosen. So we get a quadratic for B dot C. We are getting 3 times B. So you just need to find the image of S in this line, and then you will be able to get this. Hello, welcome everyone. I'm Surendra Sir, Master Teacher of Mathematics in Vedantu. In today's session, I will talk about maths difficult problems asked in JEE Mains 2025 that was conducted from 22nd January to 29th January. This is a list of difficult questions shift wise, and I have taken these questions only for maths, no physics, no chemistry, only for maths. Okay, my criteria to choose them as difficult was maybe that idea was difficult to strike, or even if it strike, you have 2-3 confusing method which one to choose, or calculation was lengthy. So this is how I have categorized them as difficult. Here in this session, I will not discuss all the questions. Actually, this count is total 45, but one session of 45 will be very long. So what I have done, I have chosen few questions, maybe some 15 questions I have chosen for this. So let us start with those questions. Before I start, let me tell you, this year JEE Mains has done really very good work, I will say, by giving very nice question to JEE students, JEE teachers. Every year we expect such questions from JEE Advanced, but this year I think JEE Mains has also given such questions. I will give special mention to those questions like 24th January morning shift, 29th January evening shift. I will take those questions one by one and I'll tell you them. Okay, so this is one question where we are given ABC as the vertices of a triangle, that is from 22nd January second shift. I have not taken any question from 22nd January morning shift. Okay, that doesn't mean questions were not difficult, but I feel that I will take first those questions which are my favorite, you can say. So this is how I have taken it. In this question, 3 vertices of a triangle are given. We are given orthocenter, centroid, and they're asking some expression. It looks like a scary expression, what exactly is going on, but I think it is not that difficult. Please see first thing here is that you have to identify that A, 6, 8, B and C are such that their distance from origin is 10, 10, 10. You can check. 6, 8 is Pythagorean triplet, distance is 10. Here also 10, here is also 10. That means for this triangle ABC, origin has to be the circumcenter. Origin has to be circumcenter because origin is having equal distance from all the 3 vertices. And then there is a mention of orthocenter and centroid. That means it has to be a question based on Euler's line. What is Euler's line? Euler's line says that orthocenter L, centroid G and circumcenter, they all lie on same line, and the ratio which centroid divide is 2:1. Already circumcenter is at 0, 0. Okay, this centroid they have given as H, K. Okay, from this you can see this L will become, from the section formula, will be 3H, 3K. In fact, let me tell you one interesting thing. Like G, we all know, is given by sum of x coordinates divided by 3, sum of y coordinate divided by 3. But in case of orthocenter, when your circumcenter is at origin, it is just the sum of all the x coordinates and y coordinates. So that means this A will be equal to the sum of the 3 things. That is 6 plus 10. I can take common, cos alpha minus sin alpha. Okay, likewise this 8 I can take as not 8, 9 actually. Yeah, this is 9 here. So that 9 will be equal to 8 plus 10 common. For y coordinate it is cos minus sin again. Cos minus sin. Yeah, both time cos minus sin. So from here we are getting cos minus sin to be equal to 1/10. Okay, so this is one relation I'm getting, and I can put it here. From here I will get A also. What will be the value of A? A will be equal to 6 plus 1, that is 7. Yeah, okay. Now what they are asking? They are asking 5A minus 3H plus 6K and so on. But before that, let us find what will be my 3H. In fact, we have now find 3H to be equal to A, and that is equal to 7. Is there K there? Yeah, K is also there. 3K is equal to 9 already. Okay, so these things are also known to us. So what they are asking is actually 5A, and 5A would be 5 into 7, 35, and minus 3H. Minus 3H is 7, and 6K is 9. Okay, and plus 100 times sine 2 alpha they are asking. Now please listen carefully. If you know this cos minus sine is equal to 1/10, I think using this, by doing the squaring both sides, you get 1 minus sine 2 alpha. See, cos square plus sine square alpha is 1 minus 2 sine cos, so it becomes sine 2 alpha is equal to 100. So from here we get 100 sine 2 alpha is equal to 99. We get 100 sine 2 alpha to be equal to 99. So this value I can put it here. So plus 99. Okay, so this is how this question should be solved. Answer to this question was coming out to be, let me see, I think 145. Yeah, you can do the calculation. What 28 plus 9, 37, I think. 1 minute. 37 plus 99. Something wrong. I think answer was 145. Let me check what I have done wrong. 5a will be 35 minus 3h. 3h is nothing but a, so that is 7, and plus 6k. 6k, that means 9 into 2, 18. This would have been 18 actually. Okay, you can check, it has to be 145. That will be 18 minus 7 is 11. 11 plus 35 is 46 plus 99 is 145. Yeah. So this is how this question is done. So you can see there are too many things they have given in the question, like coordinates, then orthocenter, centroid, sine to alpha. You have to make use of each and everything, and this Euler line. Without that, you cannot do this question. So that is one question from 22nd January shift 2. Now coming to the next question, that is again from 22nd January shift 2 only. In this question is based on binomial coefficient property. Okay, these type of questions are favorite. I always like these kind of questions. Please see how this can be done. Here this 30cr square and 30cr minus 1, you will first solve it. Okay, so this will become summation r square. I will keep 130cr as it is, and other 30cr I will write it as 30 factorial upon r factorial and 30 minus r factorial. Okay, divided by 30 factorial, r minus 1 factorial, and 31 minus r factorial. So you can see 30 factorial gets cancelled. This r minus 1 factorial will cancel r factorial, but r will remain, and this r will cancel this r square also. So we will be getting here as r into 30cr, and from here 31 minus r will come in the numerator. This is what we will be getting, 31 minus r. Here r is starting from 1 to 30. Okay, now you have to use two formulas. One is summation r into 30cr, and for that I think 31 is also multiplied outside, and minus summation r square into 30cr. Okay, if you remember these two results, I think this question is easy. Okay, otherwise if you don't remember these results, I think you will have to derive them in the exam. That will take too much time. So it is very important that you use this result and get the answer. I think after solving, what we are getting, this was coming out to be, I think 2 power 29 into 465. Okay, so this was given to be alpha into 2 power 29. So this alpha was coming out to be 465. Okay, so this question again was not very difficult, but yes, if you get to know what should be my first step and you remember these results, then you will be able to get this answer. Okay, let's move to the next question. Okay, one thing, just 1 minute, bacho. I like to give you one idea that in case, although that is not excuse, in case you are having any confusion, I will tell you one method where you can reduce this expression to easier term, and where there you can get the answer. Let me show you this thing. So what we were getting, r into 31 minus r into 30cr. I think this is what we were getting. Yeah. So what you can do, you can combine this r with 30cr. So this will become 30 common and 20cr minus 1. You can check. This is 30 factorial upon r factorial, 30 minus r factorial. If you multiply with this r and take 30 out, this becomes 29cr minus 1. And then it will be 31 minus r. Okay. Now in this case, you will not require this formula of r square. Your job will be done only by making use of r. Okay, in fact you can do similar trick one more time, and then you can reduce it in terms of 28cr minus 2. From there it will be just sum of binomial coefficient, that comes out to be 2 power n. So from there you can get the answer, but you should remember, you should understand, this thing can be done to simplify the binomial coefficients. Okay, so moving to the next question. This question is again from binomial theorem. They are asking sum of all rational terms in the expression. Okay, power is 6. Now how to do this? Maybe we can do it with the help of multinomial theorem, but we have to see in each and every multinomial term where power on 2 will be some integer, power on 3 will be integer. For that I need to have this 2 power 1 by 3 converted into 2 power 1 by 3 whole power, some multiple of 3, and similar to 3 power 1 by 2. But in my opinion, the best method for this would be, please understand, I think it will be that if we write 2 power 1 upon 3 separately and 1 plus 3 power 1 upon 2 separately. Okay, if you do this way, and I will write only rational terms. Only rational terms if I write. So first term will be rational because 6c 0, and this 2 power 1 by 3 will be taking all the powers 6 here. So this will become rational. This will be having power 0, no need to write plus. Then if you write 61 term, it will be having power 5, but this will be irrational term. So we need not to write. Similarly for 62, again this will be power 4 here, no need to write. So next time that we will be getting rational term will happen when this is 63, and then it will be 2 power 1 upon 3 raised to the power 3. And that remaining power 3 will go to this thing. That is 1 plus 3 raised to the power 1 by 2 power 3. Here again we have to take care of which term will be rational, because all term will not be rational here. So that we can take care of. Similarly, the last term, that is 66. Okay, that will give you the power on 2 power 1 by 3 as 0. So we will be having just 1 plus 3 power 1 upon 2 power 6. Okay, now again I will write only rational terms. So this will be 2 power 2. So this is 4 here. 63 is 20. This becomes 2. Now out of this is cubic term. So first term is 1. The next term will be having 3 power 1 by 2. After that, this term will be 3 power 1 by 2 whole square. So this will become 3 into 3, and that's it. These are the rational term here. Okay, the last term will be having 3 power 3 by 2. So that also need not to be taken care of. Here 61 is 1, and in this case I think first term will be 60. Then 61 will be having irrational term. Then 62 will be having 3 power 1 plus 64 3 power 2 and 66 3 power 3. Okay, actually in this approach, in this method, you will not miss out any of the term. When I did this question for the first time, I tried this question with the help of multinomial theorem, but there was some error which I got in first attempt. So that's why I'm saying that will be the best method in which you will not miss out any of the term. I think answer of this question after simplification comes out to be, I think, 612. This was 23rd, yeah, 23rd January. The answer of this was 612. Yeah. 612 was the answer of this question. Okay, so moving to the next question. This question, yeah, that is very good question. This question is from definite integration reduction method. Some people say gamma function, beta function, Wallis formula. Okay, if you remember all these results, then I think definitely you can do it. But normally people don't remember it. Either they remember Wallis formula, or they try to do that reduction method in the exam itself. Okay, here what I will use, let me tell you in my method, and I think everybody should remember that formula, and it is 0 to pi by 2 sine power mx into cos power nx dx. This integral we should remember. What is this? I think this is in the denominator, it is m plus n, and then m plus n minus 2, and so on. It will keep reducing. It will end either at 1 or it will end at 2. In the numerator, it will be m minus 1 reduced by 2 once again, m minus 1 minus 2, and so on. Again, it will end at 1 or 2, and similar for n also. Similar for n also. So that is the formula I'm going to use. Now in this question, IMN, if you try to find, to solve it, I think the first thing would be that we put x is equal to sine square theta. If you do that, your IM comma n will become equal to 0 to pi by 2. Okay, this x power m minus n will become sine power 2 m minus 2 theta. This will become cos of 2n minus 2 theta, and dx will become 2 sine theta cos theta. 2 sine theta cos theta d theta. Okay, here after simplification, that 2 can be taken outside, pi by 2, and this becomes sine 2m minus 1 theta cos of 2n minus 1 theta d theta. This is what we are getting. Now we can open this integration with the help of this formula. Yeah. So we will be getting this to be equal to 2 times. In the denominator, it will be 2m plus 2n minus 2. And every time you will reduce it by 2, so we will be ending at 2 because all are even numbers. In numerator also, because we have to reduce it by 1, so it will become 2m minus 2 here, then 2m minus 4, and so on. It will also end at 2, one bracket, and other bracket in place of m, it will be n, so 2n minus 2, and so on, 4 and 2. Okay, if you take 2 common from every bracket, I think it will be common m plus n minus 1 times here, m minus 1 times here, and n minus 1 times here. Okay, so you can see with the help of this 2, all the 2 in the numerator and denominator will get cancelled, and we will be having m minus 1 factorial, n minus 1 factorial upon m plus n minus 1 factorial. So this is what we are getting for this question. Okay, now in this question, this was not enough. You have to find I 9, 14 plus I 10, 13. Let me tell you, you can combine these two with the help of reduction method also, that you start with 9, 14. Okay, try to do integration by parts. You will get one part of the integral in terms of I 10, 13 and I 9, 14, and that's a very standard way. We combine 9, 14 on one side, 10, 13 on the other side, and we get combined thing together. But if we have got this result, I think you can now find this also directly. So my I 9, 14 plus I 10, 13 would be, after knowing this thing, it will be 8 factorial, 13 factorial upon, I think, 22 factorial. Yeah, plus in this case it will be 9 factorial, 12 factorial upon 22 factorial. I think in both of them it is 23, so 22 factorial. Okay, so if it is 22 factorial in both of them, both cases, I think if you combine them together, you will be getting this to be equal to, I think 8 factorial can be taken common from here, 12 factorial can be taken common from here, then we will be having 13 plus 9, so 22 into 8 factorial, 12 factorial, 8 factorial common, 12 factorial common. After that we have 22, and in the denominator we have 22 factorial. 22 factorial, actually I can cancel 22 also, so we will be getting 8 factorial into 12 factorial upon 21 factorial. Now we have to check which one of the option, because we cannot get this answer directly in terms of options. You have to check each and every one. But I think if you know this result, you can eliminate many options. Like in this case, in the denominator you will be having 19 plus 26. After doing that minus 1, it will be a huge number, so we cannot get this equal to this thing. Similarly here it will be 14 factorial in the denominator, only 14 factorial, whereas we need 21 factorial there. So I think this seems very close to this thing, and you can check that this third option, it will become equal to 8 factorial into 12 factorial upon, I think, 21 factorial direct. Okay, so this is the answer of this question. So in my opinion, this question was not doable, or rather, if doable, at least 5 to 7 minutes this question will take in the exam. After you know this result, okay, or you have done by reduction method, but then you have to be very quick and precise without doing any error. I think you can do it by taking this as first function, taking this as second function, then imn gets converted into im plus 1 comma n minus 1, and by looking at the pattern, actually that is the proof of this kind of reduction method. So that if you do in exam, it will take a lot of time, so we should remember at least this thing. Okay, Shali. So let us move to the next question. Yes, that is the favorite question. That was the favorite question, let me tell you, Bacho. And I took too much time solving on that. In multiple ways I did this question, and then I found one very good method. I will show you what was that method. Please see. We are given a quadratic in which 2 iota is there in the constant term. Alpha and beta are the roots, and we have to find this real into imaginary of this. Okay. So what is the special about this question? Please see. Alpha plus beta is equal to, I think, 3 upon 2, and alpha into beta is equal to minus iota. Okay, now alpha into beta is minus iota, and here if you see the difference of power here, 19 to 11 is 8. Alpha to alpha, beta to beta, and denominator you are having power 15. So maybe we have to try something like that. We can write a relation where difference of power is 4 or 8, something like that. Okay, now if I take power 4 here, alpha and beta, alpha power 4, beta power 4, I think this will become equal to 1. Now listen carefully. If this is equal to 1, and I assume I try to make a quadratic whose roots are alpha power 4 and beta power 4. Okay, quadratic with them as roots. Okay, now what you can see here is, then it will be x square plus alpha power 4 plus beta power 4, and let me call this as s4 for some time. Okay, and into x, sorry, there will be minus sign, not plus. This will be minus sign here, and plus 1 equal to 0. Okay, now for this quadratic whose roots are alpha power 4 and beta power 4, okay, if you put it here, you will be, this alpha power 4 should satisfy it, so we will be getting alpha power 8 minus s4 into alpha power 4 plus 1 is equal to 0, and likewise for beta also. Now I can multiply this entire thing by 11 so that I get alpha power 19. This will become alpha power 19, and I will take this one first, so this will be alpha power 11, and that will become equal to s4 alpha power 15. What I have done in this equation, I have multiplied by alpha power 11, and I am getting this thing. Now same thing I will get for beta also. So beta power 19 plus beta power 11 is equal to s4 into beta power 15. I think we are done. Please see. what I did, alpha beta is minus iota, so alpha power 4 beta power 4 will be 1. Now a quadratic with roots alpha power 4 beta power 4 will look like this. Now alpha power 4 should satisfy it. So if I multiply by alpha power 11 in this relation, I will get this thing, alpha power 19 plus alpha power 11 is equal to S4 alpha power 15, and likewise for beta. Now if you add them, okay, so that alpha power 19 plus beta power 19, let me call that as S19 plus here S11 will be equal to S4 times beta power 15. Now you can see this expression for which real and imaginary part is sought actually is nothing but this S19 plus S11 upon oh, I think here again, not beta power 15, this will be S4 into S15 actually. So S15 here is equal to S4. Okay, so you can see that real part of S4 into imaginary part of S4 is all we need to find. Okay, so what we are looking for, 16 times real part of S4 into imaginary part of S4. Now we have to find S4, and what is S4 here? Because S4 is nothing but alpha power 4 plus beta power 4. I think that we can find out by multiple methods, maybe by transformation or using sum of roots, product of roots. You know, alpha plus beta is equal to how much? 3 by 2, and alpha beta is equal to minus iota. So from that we will get first alpha square plus beta square, one very standard way. I think in 9th grade, 10th grade student also do this thing. So that will be 9 by 4 minus 2 alpha beta. So it becomes 2 iota. Okay. Now once again, to find this thing, I think we will be doing alpha square plus beta square whole square minus 2 alpha square beta square. Okay, what will be the whole square of this thing? I think it will be 81 upon 16, or let me do one thing. Yeah, let me do one thing. Let me write it as 9 plus 8 iota upon 4. Okay, so alpha square plus beta square would be, whole square would be square of this thing. So 81 minus 64. 81 minus 64 is I think 17, and plus 9 into 8, 72 into 2, 144 iota upon 64. Okay, minus 2 alpha square beta square. I think alpha beta is minus iota, so alpha square beta square will be minus 1, so it will become plus 2 here. So this becomes 64 into 2, 128 plus 78. 128 plus 78 is how much? I think this was coming out to be 1 minute. This is 16. How I am writing this as 64. This is 16 only. So 9 square is 81. 81 minus 64 is 17. Yeah, that is right. So 32 plus 72. 32 plus 17. 32 plus 17 will be 49 plus 144 iota upon 16. Yeah, I think this is now right. The same thing I was getting there at that time also. So this is what we are looking for. Now what they are asking, 16 times the product of real, 16 times the real part, that is 49 upon 16, into imaginary, that is 9 only. 16 if you divide 144, so you will be getting 49 into 9, that is 441. So answer of this question is 1. That was the best question, I will say, in all shift together. I will if I say one question, I think that was the question which I will remember, you know, till 1 year, 2 year, 3 year, you can say. There are few more questions that are good, but I think this was best question, I will say. Now coming to the next question. Yeah, this is also one very good question, lecture. Okay. Now here we are given A as a 3 into 3 matrix such that xt into A into x is equal to null matrix for all non-zero 3 into 1 matrix X. Now listen carefully. This thing, when xtax is null matrix for all X, in that case what should be my A? You can take A as A, B, C, D, E, F, G, H, I. Okay, then also you can do it. Actually, please check. This X is actually 3 into 1 order. So xt will be 1 into 3 order, and A is 3 into 3 order. So if you multiply all of them, I think this will be 1 into 1 element actually. So that will be 1 into 1 element, means if you take the transpose of this entire thing will be same thing, because it is just 1 into 1 matrix. So taking transpose will give you the same thing. So it can be written as xt at into x again. Okay, so for any x, for any A, this the transpose of this has to be equal to this thing, and that will be equal to xtax. Why they both are equal? Because it is 1 into 1. If you take transpose, it will not make any difference. Now please see, this is going to be equal to this thing always. Okay, now they are saying this xtax is equal to 0 for all non-zero 3 into 1 matrix, means you don't have to choose any xyz. For every xyz, it has to be 0. So please listen carefully. This can be made equal to 0 only if this is equal to negative of itself. Okay, this is equal to the negative of itself, yani ki minus xt ax. If it is 0, then it has to be equal to minus of itself. So here you can see, suppose you can have a like that, where at is equal to minus a, at is equal to minus a, then this will always become equal to 0. You don't have to rely upon x. What I'm trying to say that, let me repeat once again, this is equal to transpose of this. If you use the property of transpose, you get this thing. Okay, now if you want this thing to be equal to 0 for every value of x, y, z, then having at equal to minus a. Okay, if at is equal to minus a, you don't have to rely upon x. This will be equal to minus of this thing. That means this will become equal to 0. So what I'm saying, that this relation is equal to 0 for all such capital X only if a is skew symmetric. That means at is equal to minus a. Please listen to my video once again if you have not understood it. But in this way, I have directly concluded, although you can do it separately also. Let me do that also, bacho. Please see how we can do that. Okay, I'll do this on the separate slide. Suppose this xt, okay, xt would be x, y, z, and let us take a as a, b, c, d, e, f, and g, h, i. Okay, and x here is x, y, z. Okay, now if you multiply them, so first x, y, z, I am writing it here. If you multiply this with this, it will be a column matrix, first row with first column, so it becomes ax plus by plus cz. Then it will be dx plus ey plus fz. Then it will be gx plus hy plus iz. Okay, now if you multiply this with this, just one element will come, row, column, and you can see it becomes ax square plus ey square, ax square plus ey square plus iz square, plus for xy term will come when this x is multiplied with this and this y multiplied with this. So it will be b plus d, and yz will come when this y is multiplied with this f and this z is multiplied with h. So f plus h plus zx will come when this x is multiplied with this z. So c plus g, I think c plus g. Now you want this to be null matrix, this to be 0 for every x, y, z, then it is true only if all the coefficients a, e, i, and so on, they are of 0. So when this happens, I think this a, e, i has to be equal to 0. Okay, a, e, i has to be 0, 0, 0, and sum of b plus d, c plus g, and f plus h has to be equal to 0. That means it will become skew symmetric matrix. Okay, so this is what I was telling you from here also. Now, once you know this thing, I think you can find the coefficients, you can find the elements of A, and then you can get the answer. Okay, let us do this. So my A is, let us say, 0, A, B, minus A, 0, C, and minus B, minus C, and 0. That is my A. Okay, now if I multiply A with this 1, 1, 1, my first row will give you, I think, this A plus B is equal to 1 here. And in the second multiplication, it will be 2A plus B is equal to 0. First row, this column will be 2a plus b equal to 0. You can solve them. You get a to be equal to, I think, 1, minus 1 rather, and b is equal to, I think, minus 2. A is equal to minus 1, b is equal to 2. B is equal to 2. Okay. Similarly, we do it for second row. So this second row, minus a plus c will be equal to 4. And we know already value of a, that is minus 1. So c will be equal to 3. Okay, what is remaining? I think a is found, b is found, c is found, everything is found. So I think this is done. In fact, you can check for other multiplications also. Like if I do this multiplication, minus a 0 c with this, I'll be getting minus a plus c only. That is equal to 4. I think it is same thing. If you multiply third row of a with this, that is minus b minus c. So minus b, minus 2 ho gaya, minus c, minus 5. So we are getting minus 5 here. Same for this also. So we have got now a. Now we have to find the determinant of adjoint of 2 times a plus I. So what will be my a plus I now? A plus I is nothing but in the diagonal position where we were having 0, 0, 0, we'll get 1, 1, 1 now. 1 a is minus 1 and b is 2. This will be 1, this will be 1, and c we got 3. So here it will be minus 2, this will be minus 3, and this will be 1. Okay, I have done the calculation. I'll write the answer directly. that determinant comes out to be 15. You can check. Okay, now this thing you can do in multiple ways. What I do is this thing would be actually equal to square of determinant of 2 times a plus I. Square of determinant of 2 times a plus I, because determinant of adjoint of anything for 3 into 3 order is like this only. Okay, a plus I determinant is 15. Determinant of 2 times, because it's a 3 into 3 order, so 2 power 3, 8 will get multiplied, so it will become 120 power 2. So that is how this is what you should get for this determinant. Now you can find the values of alpha, beta, gamma. Let me write it directly. Alpha, beta, gamma comes out to be, I think, yeah, I'll write it here. Alpha comes out to be 6, beta comes out to be 2, and gamma comes out to be 2. So I think from there your answer will be 36 plus 4 is 44. So this is how this question is done. See, in this question, again I will say, when you get this kind of thing, you don't understand how to start it. Once you realize that it will be just 1 into 1 element, I think you can do this question in this method. This is not that obvious. I agree with you. I think in fact myself was not able to understand in my first method. Later on I realized, in fact, this kind of concept I discussed 2-3 years back with one of my students. So it I remember that this thing will be only 0 for all x when A becomes skew symmetric matrix. So there was some discussion, something like that. So that's why I'm mentioning it here, but it is not that obvious. After that, I think this question becomes doable, but still calculation is large. And please see, even after getting this A, they want you to find A plus I, then they want to find the determinant of adjoint of 2 times A plus I, and then alpha beta gamma, then alpha square plus beta square plus gamma square. So you can see how much they are expecting from you. Okay, and at any step you do any error, I think your marks are gone. Okay, so that is something that you have to take care of. Now this question is from 28th January shift 1. This question is from recurrence method. Actually in RMO, INMO, we do this kind of thing where using characteristic equation we solve such kind of questions, but here it was not that difficult. Here you can do it by some observation also. Please see how that can be done. Here if I write this relation 2an plus 2 minus 3 times an plus 1, and on the right side it will now remain 2an plus 1 minus 3an. Now you can see on both sides you are having similar expression, 2 minus 3, 2 minus 3, here n plus 2, n plus 1, n plus 1, n. So you can see from this pattern, we can write this again as 2an minus 3n minus 1 also. In fact, we keep on writing like this. The last one would be 2a1 minus 3a naught. And the values are given like that. This becomes equal to 1. This becomes equal to 1. Okay, so here you can see that this 2an minus 3an minus 1 is equal to 1. And we are looking for a1 plus a2 up to a100. Let us put n is equal to 1, 2, 3 up to 100 and add them. So the first thing will become equal to 2 times a1 plus a2 and so on up to a100 minus 3 times. If you put n is equal to 1, your first term would be a0, then a1 and so on, and the last one would be a99, and that will be equal to 100 on the left side. Now if this thing which we are looking for, if I call this as s, okay, then this is directly s only. But in this bracket, I think we should have started with a1 and this should go till a100. So if I write s, then I have to subtract a100 and I have to add a0. Then only this bracket can be written like this, and this is equal to 100. Here a0 is 0, we are given. So you can see that s, if I bring this 2s minus 3, that is minus s on the other side, it will become, I think, 3 times a100 minus 100. So this is how this question is solved. Okay, I think this is the best method, no doubt about that. But yes, there can be other method in which you write a characteristic equation of this recurrence method, that is nothing but similar to writing a quadratic. Here you can see it is 2an plus 2, so highest degree for this, so 2x square. One less degree here, it will be 5x. One more less degree, so only constant term here. So from this characteristic equation, 2x square minus 5x plus 3 equal to 0, whose roots are, you can check, they have 1 and 3 by 2. Okay, now in such question, your an becomes equal to some constant time 1 power n, first root, plus b times 3 upon 2 whole power n. Now to get these values of a and b, we will make use of a0 and a1. If you put n is equal to 0, it becomes 0. This is a plus b. If you put n is equal to 1, it becomes half, which will be a plus 3 by 2 into b. Now from there, you can get a and b both, and then you will get explicit formula for an. By using that explicit formula also, you can find this summation. Okay, So that is other method. Now coming to this question, this is I think 28th January morning shift. Yes, this question is I think bit difficult, not very difficult. You have to understand what exactly they are saying. So much information. Huh? M denote the set of all real matrices of order 3 into 3, and S is a set of 5 element minus 3, minus 2, minus 1, 1 and 2. And then we are given S1 set of A equal to Aij belongs to M. That is the real matrix where A is equal to 80. That means it has to be symmetric matrix. Okay, and Aij, all Aij belongs to the set that S 5 elements. Okay, then S2, the condition is of skew symmetric. All elements from that S. S3, there is additional condition, or rather there is a condition that sum of diagonal elements should be 0. Okay, there is no other condition, no symmetry or skew symmetry, but sum of diagonal element has to be equal to 0. Then they are asking sum of S1 union, number of elements in S1 union S2 union S3. First of all, because S is not having any 0 element in it, okay, and S2 is actually skew symmetric matrix. We just saw in one question also. Here, because we are not having any element 0, 0, 0, so you cannot create any skew symmetric matrix here. So this S2 will be equal to 5. Okay, if this is equal to 5, then this becomes equal to number of elements in S1 union S3 only. That means it will be n of S1 plus n of S3 minus n of S1 intersection S3. Okay, now this we can calculate easily. S1 was number of elements which are symmetric matrix. Now symmetric matrix means you need to have only 6 elements. You are free to choose only 6 elements. How I am saying? See, this is suppose your A, B, C, D, E, F, G, H, I. Okay, so diagonal element you can choose freely, but whatever B you choose, you have to keep B like that only. Similarly, C will be equal to G, F will be equal to H. So I can choose only 5 elements, and for every element, I can choose only 6 elements, sorry, and for every element, I am having 5 choices. So for this thing, it will be 5 raised to the power 6. 5 choice for this, 5 for this, and so on. So 5 raised to the power 6. Now for n of S3, this was a bit tricky. Please see, because we want sum of diagonal element, that is A plus E plus I, to be equal to 0. Now please see, if we want this sum of diagonal element to be 0, where elements are from this, so this sum can be 0 only if some elements are negative, some elements are positive. So let me say only one element is negative, and that is minus 3. Okay, or maybe you can say if minus 3 is one negative element, you cannot keep another negative element, because you cannot have then sum equal to 0. So to have sum equal to 0, where one element is minus 3, your other two element has to be 1 and 2 only. 1 and 2 only, then only this sum will be equal to 0. In fact, this can be rearranged in this diagonal in 3 factorial ways, that is 6, because all are different. Okay, with minus 3, there is no other possibility. You take minus 3 with minus 1, then you cannot have sum equal to 0. I think that's the only thing possible. Then coming to minus 2, if one element is minus 2, negative number minus 2, then other element, if you take minus 1 also, then also your sum cannot be equal to 0. So this will be 0 only if you take like this. Okay, in this case, because 2 elements are identical, so only 3 choices, 3 arrangement will be there to have this minus 2 plus 1 plus 1. Similarly, if you take one element minus 1 here, okay, and minus 1 here, and yeah, minus 1 2 times you can take, and 2 from here, then also it will become equal to 0. Okay, with minus 2 we have checked, there is no other possibility. You cannot take minus 2 times, or minus 2 with any other element. But when you are taking minus 1 and you want sum to be 0, then there have to be some other negative element, that is minus 1, then only your sum will be equal to 0. And this is done in 3 ways. 6 plus 3 plus 3, that is 12. Okay, so there are 12 ways to write your diagonal elements. And in S3, other 6 elements are free to be chosen. So 5 raised to the power 6 will come here, and minus their intersection. Intersection means it should have sum of elements to be 0 also. That can be done in 12 ways, and then it should be symmetric also. That means only 3 elements to be chosen. So 5 power 3. So this is the calculation that we need to do. So let me see what is the answer. I'll write the answer directly. I think this is coming out to be in terms of 5 power 3. So I can take 5 power 3 common. That will be 125 plus 12 into 125. 12 into 125 minus 12. Okay, and this is my answer, and you can solve it. It comes out to be 1613. 1613. Okay, so this completes this question. Moving to the next question. This was also, I think, not easy question, I will say. Many chances that you do some calculation wrong here. Okay, yeah, this question is very good question actually. In this question, I found how to find B dot C little tricky. I did it in 2 methods. We are given A, B, and D as A cross B, and C is a vector such that A dot C is equal to C, and C minus 2A square is equal to 8. Okay. Now in this question, yeah, I will first solve for this thing, and that A dot C is equal to C. I think I have seen such question before, maybe in some JEE Advanced or some paper. If you square it, you will get C square plus 4A square minus 4A dot C is equal to 8, is what we are given. C square, A square is actually 3, so it becomes 12 minus 4A dot C is 4C is equal to 8. Now you can see it becomes C minus 2 whole square is equal to 0, which means the mod of C has to be equal to 2. So that is one thing that we have obtained. Okay. Now we are given angle between D and C as pi by 4. Okay. If that is so, that means your D cross C magnitude will be equal to. And one more thing, this A and B, you can do the cross product easily. Your D comes out to be minus I cap plus j cap. Simple vector product, you can get this minus I cap plus j cap. Magnitude of D will be equal to root 2. Magnitude of C is 2. Angle between them is pi by 4. So sine pi by 4. So we get this to be equal to 2. Mod of D cross C is coming out to be 2. This root 2 will get cancelled, but we are looking for square. Okay, we will take care at that time. Okay, so that is one thing that we have obtained. Now, how to find this B dot C, or rather 10 minus 3 times B dot C? Please see how this I have done it. I first thought that I will take C as maybe xi plus yj plus zk. Okay, and because angle between C and D is pi by 4, so we will get one relation from here. Okay, and magnitude of C is 2, one relation from here, and then with B dot C we can get the answer. I think that is also one method, but let me do some other method. B dot C, if we have to find, B is already A cross B. Okay, actually I use this relation. Yeah, B is A cross B. Okay, and cross C, the magnitude is equal to 2. Now I will use vector triple product, so it will give you A dot C, that is C, and C is 2, so 2 times B here, minus B dot C, that is what we are looking for, into vector A is equal to 2. Let us do the squaring both sides. So this will become 4B square, and let me first write 4B square, and then plus B dot C square A square, and minus 4B dot C, 4B dot C into A dot B is equal to 4. Now we know what is B square. I think it is 9. So 9 into 4 will be 36. Okay, A square is just 3. So it is 3 times B dot C square minus A dot B, you can check, it is I think 5. So 5 into 4, 20 into B dot C is equal to 4. So we get a quadratic for B dot C. We are getting 3 times B dot C square minus 20 times B dot C is plus 32 equal to 0. Okay, now you can solve this quadratic. You will get two values of B dot C. In fact, they have asked in such a way that whatever value you get, your answer will be same. Okay, what we are getting, let me tell you, let me do it. 3B dot C, 32 into 3 is 96, and this can be broken like 12 and 8. So that will be 3B, sorry, yeah, 3B dot C, 3B dot C minus 8, one factor. Okay, and other factor will be B dot C minus 4 is equal to 0. Let us just check. 3B dot C square, and that will be minus 12 minus 8, so minus 20, and 32 is equal to 0. So we get 3B dot C value to be equal to 8, or from here it will be 12. And you can see 10 minus 8 or 10 minus 12, they both are 2. So my answer becomes 2 from here and 2 square from here. So answer becomes equal to 6. Okay, they have done it beautifully, that they got B dot C as 8 and 12, and then they placed a mod on 10 minus 3 B dot C, so that whatever you choose, you get same answer. It may become a bit confusing that we are getting two answers, but still we may get two answers, but they are asking 10 minus 3 B dot C. But this doesn't look clear that from the beginning when we are doing the calculation, that it will give you same value for both the values of B dot C. So this is how it is done. So this complete this question. Yeah, I was telling that method. So I will not do it, but I'm just repeating what I said. Starting with C is equal to xi plus yj plus zk, and then use this relation. Okay, and using that angle between D and C is pi by 4, you can find the condition on x and y, and then B dot C from there also can be found. Okay. Moving to the next question, that is 28th January shift 1. Okay, in this question, let me first expand this thing, what they are asking. It is 1 plus, this will become 1, 12C1, then it will be minus 3, 12C3, then plus 3 square, 12C5, then minus 3 cube, 12, 12. 12C7 plus 3 power 4, 12C9, I think, minus 3 power 5, 12C11 is what you are getting. Okay, because whenever you increase R by 1, this will be 1, then 3, then 5, then 7, then 9, then 11. For 6, it is 11. When you put R as 1, 2, 3, then you will be getting 3 power 0, then 3 power 1, 3 power 2. Alternate positive negative sign will also come. Okay, now in this question, what we need to understand, we are having alternate binomial coefficients, binomial terms, okay, and also alternate positive negative terms. So what we do in such questions, we write expressions like this: a plus b square, a plus b power n, and a minus b power n. If you add, then your first term will get added, second will subtracted, third will added, fourth will subtracted, and so on. Now because we are looking for 12C1 term first, so maybe I think minus sign will come, not plus sign here. Minus sign will come. But there is one more problem, that if you take this kind of relation, this kind of expression where a and b are real numbers, your all the terms after calculation will be positive, 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 no negative sign. So if we want a negative sign to be there, I think we need to keep something like iota, like this. Now you can check why I'm saying iota, because iota, because terms, alternate terms will be cancelling, alternate term will remain. And in case of iota, if you increase power by 2, you get minus sign, you get extra minus sign. So it will be having plus then minus, and so on. So keeping that into our mind, I think we can write the expansion of this thing as, we see, 1 plus root 3 iota power 12 minus 1 minus root 3 iota power 12 whole divided by 2 iota. You can check. This expansion of this would be, let me write it here. First 3 terms I will write. It will be 12C0 plus 12C1 into root 3 iota plus 12C2 root 3 iota square, and so on. For this, it will be plus, minus, plus, and so on. When you subtract, this will cancel, this will also cancel. Terms like this will remain. In fact, the next term that will remain would be 12C3 root 3 iota power 3, and so on. Okay, this will remain. But what we are looking for is, I think with 12C1, we want just 1, 2 multiplied. So what I have done, not 2, also root 3 will be dividing it here. So 2 iota and root 3 will also divide it here. And 2 is because this term in the expansion of this and the same term in the expansion of this will get added. So I divide 2 also to get this 12C1 term here. Similarly, for this another term here, 12C3, you will get minus sign here in the expansion of this. You will get here also, when you're adding, they becomes 2 times, and you will get 12C3 and 3 root 3 here, and into 2 also there. So 2 root 3 will cancel, iota will cancel, and this expression will give you exactly this expression which is given in the question. Okay. Now the question is how to solve it. I think to solve this question, you need to check that this is a complex number whose argument is 60 degree, pi by 3. Here it is minus 60 degree. So if power 12 is there, the resultant of this thing will have argument equal to 12 into 60, that is 720 degree. So that will be a real number. Okay, this will also be a real number. They are having same magnitude, so they will cancel each other. So that means it will just be equal to 1. Okay, now this entire thing will be just 0. You will get just 1. And then I think question is very easy. You have to find the distance of this point from this line. Distance formula you have to put. So 12 into alpha. So I think only 12 here. Root 3 if you put, so minus 3 plus 1 upon 2. So it will become, I think, 5. 12 minus 3, 9 plus 1, 10 upon 2, so 5. Yeah, 5 is the answer. Okay, coming to the next question of shift 2. Here, I think very popular question. You might have seen this question at many places. I still chose this question because I just wanted to tell you something about this question. First of all, B is given P, A, PT, and C is PT and B power 10. So that means it will be PA, PT power 10. I'm writing it as PA, PT PA, PT 10 times and P here. Okay, last bracket also, let me write it here. PA, PT and P here. Now you have to check this P with PT will be equal to I. Actually, it's a orthogonal matrix. Every row is having squares, sum of the squares has 1. And if you take the dot product or product of the rows, I think it becomes 0. You can check P into PT is equal to I, that is identity. So PT into P will be I, PT into P will be I, PT into P will be I. So everywhere you will get I, only A will remain, and that is 10 times. So it will be equal to A power 10. A is this matrix. Okay, now they are asking the sum of diagonal elements of A power 10. Now how to do this question? Maybe you will find A to A square, A power 3 and so on, and you will look at the pattern and then you will write the sum of diagonal elements. But I'll tell you another method. If you have done that eigenvalue theorem things, then it will be very easy. The characteristic equation, if I write A minus lambda I equal to 0, okay, you can see it becomes lambda minus 1 upon root 2 and lambda minus 1 is equal to 0. So eigenvalues are 1 and 1 upon root 2. Now there is a property that if eigenvalues for A are 1 and 1 upon root 2, or rather alpha and beta, then for A power 10, eigenvalues would be the power of these two. That means 1 power 10 and 1 upon root 2 power 10. And that is 1 and that is 1 upon 32. Okay. And trace is always sum of the eigenvalues. So trace or that sum of diagonal element, that is m upon n, will be equal to 1 plus 1 upon 32. So this becomes 33 upon 32, and we need to find m plus n, that is 65 here. Okay, so that is the method. If you know the concept of eigenvalue and this diagonal element sum is equal to the sum of eigenvalues, then it is very easy. Else you will have to find the pattern. You will have to see the pattern, what pattern is there. Like if you find A square, you can see it will become this into this, so 1 upon 2, and this will be that is first element, first row, first column. Then first column will be minus root 2 minus 2. Oh, then it will be 0 0. Then it will be minus 2 plus 1, so 1. Okay, you can see for A square eigenvalues are 1 by 2 and 1. That is same as I was saying, that because for A, for 1 and 1 upon root 2, for A it will be square of them. Okay, now you can see whenever you are doing this multiplication A cube, every time you will find that on this diagonal position your elements are like this only. You will get some not so good looking number here, this will be 0, but every time you will get 1 upon 2 root 2, then 1 upon 4. Here it will always be 1. So from the pattern you can tell the answer. But this was, I think, much better if you know characteristic equation, Cayley-Hamilton theorem, some eigenvalue properties, then it is, I think, much easier. Yeah, this question is, I think, based on one question in JEE Advanced, if I'm not wrong. What they are saying, A and B are 2 points of intersection of line x plus y is equal to 0 in the mirror image of parabola. A and B are the 2 points of intersection of line and mirror image of the parabola. Okay, so what they are saying, there is a parabola, y square is equal to 4x, and mirror image of this parabola with respect to the line x plus y is equal to 4, which will be somewhere here. Okay, x plus y equal to 4. We have to take the image of this parabola, although not needed, but just to explain you, I will tell you this thing. If you take the image, see this point is minus 4 comma 0. This point is 0 comma minus 4. Okay, this is 0 comma 0 for vertex. The image will come at this point, that is minus 4 comma 4. You can say it directly or you can find it through the formula also. Okay, and please see this line is at 45 degree. So when you are taking the image of this parabola, it will become downward. From the image you will get the parabola becomes like this. Okay, something like this. Yeah. So what they are saying, A and B are 2 points on points of intersection of line x plus y is equal to 5. X plus y equal to x plus no, sorry, not this x plus y. A and B are 2 points of intersection of the line y plus 5 equal to 0. That is y is equal to minus 5. So the line will be somewhere here. This is y is equal to minus 5, and this line y is equal to minus 5 will intersect this line at 1 comma minus 5 point. And these points are A and B. Okay. A, D denotes the distance between A and B. Now, what will be the distance between A and B that we can find? To find this, please understand. To find this, I think we can, one method is that we can find the exact equation of this reflection of the parabola. The other method would be, please see, instead of taking the image of parabola in this line, if I take the image of this line, y is equal to -5 in the same line, which will be nothing but this line that is parallel to y-axis, because it's a line which is making 45-degree angle with x-axis or y-axis. In some sense, you can say, so the image of this y is equal to -5 will be this line, which is nothing but x is equal to 1. So what I can say, that distance between A and B will be same as distance between this A dash and B dash. So no need to find the equation of this parabola, rather this distance D you can find from here also. In fact, for this parabola, this x is equal to 1 is actually the focus. Focus is lying on that line, so this is 1, 0. A dash will be 1, 2. B dash will be 1, -2. So this D distance will be equal to 2. This is 2 here, it has to be 2 here also. Okay, then they are also asking A denote the area of triangle SAB. S is here, AB is here. I think the area can be found. This base of this triangle is 2, not 2, I think it is 4. It is 4. Okay, and if I make this triangle, the height of this triangle will be, this is at x, y is equal to -5, the height will be 5, I think. So the area they have denoted by A, that will be 1/2 into 4 into 5. This becomes 10. And they are asking A plus D. So A plus D would be 40. That is the answer. Okay. In this question, by introducing the concept of image, they have tried to confuse you, but there is no need to find the area of this parabola. In fact, let me tell you, instead of finding the area of A, B, S, you could have done one more thing. You could have found the area of the triangle A dash, B dash, and joined with the focus of this parabola in the image. Okay, and this image you can find by getting the image of this S in that line x plus y plus 4 equal to 0. So you just need to find the image of S in this line, and then you will be able to get this. Okay. So this is how this question is done. Now coming to the next question. Yeah, this question also I think is good question. Please see what is there in this question. This is 28 January. If you take this angle as theta, this is tan theta plus tan cube theta upon 1 minus tan square theta. If you take tan theta common, then you can see it becomes 1 plus tan square upon 1 minus tan square, which is actually formula of cos 2 theta in denominator. Tan, if I write it as sine upon cos, it becomes sine theta upon cos theta into cos 2 theta. Sine theta can be written as sine 2 theta minus theta. And then you can see it becomes difference of tan 2 theta minus tan theta. Tan theta minus tan 2 theta minus tan theta. And then you are given this series in which if you start writing r as 0, your first term will become, I think, tan x minus tan x by 2. I took this as theta. So if you put r is equal to 0, it becomes x by 2. 2 theta will become x. Okay. Next time when you put r is equal to 1, this will become tan of x by 2. And here it will be tan of x by 4 and so on. Okay. And it will go till infinity. So the last tan will become actually 0 because x upon infinity will be 0. So that will be 0 only. So here what we are getting, it is just tan x. We are getting tan x. Okay. Now we will use this fx as tan x in that limit and we will get the answer. I think that is not difficult. This limit will become x approaches to 0. We got fx to be tan x. If you take tan x common, it is e power x minus tan x minus 1 upon x minus tan x. So very standard limit, I think. Trigonometric limit you can say. No, not trigonometric. Exponential. E power t minus 1 upon t, where t is tending to 0. So this will be 1. This will also be 1. So answer for this question will be 1. Okay. In this question, a small comment I will give, that in JEE Advanced, whenever they give this kind of question, they always mention that x cannot be equal to pi by 2 or odd multiple of pi by 2 in some way or the other, so that this question have some domain also associated with it. Because whenever tan x is coming, we have to be a bit cautious. Okay. Although it will not make difference to the answer of this question, because in any case we are going limit x approaching to 0. Okay. But if they give that thing, that will be better. Okay, now coming to 29th January shift 1. Yeah, this is also, I think, yeah, good question. Yeah, good question. Yeah, please see. Here they are saying two parabolas have same focus 4, 3, and their directrices are x-axis and y-axis respectively. If parabolas intersect at point A and B, we have to find distance AB square. So your focus is somewhere here 4, 3 for both. For one parabola will be like this, because they are giving that directrix is y-axis, and other would be something like this because the directrix is x-axis. So they will be like this. Now please see, they will be intersecting at some point, maybe this point or this point. One very important thing to notice here is, suppose this point is alpha beta, this point is alpha beta. Okay, its distance from focus is, let us say, d. Now because this point of intersection lies on both the parabolas, its distance from x-axis, that is directrix of this right opening parabola, should be same as d. Distance from this x-axis, that is the directrix of upward parabola, will also be same as d. So this should be d, this should be d. That means at point of intersection, whether this alpha beta or this gamma delta, these two has to be equal. Alpha should be equal to beta and gamma is equal to delta. So for point of intersection, if we know from the beginning that at point of intersection x coordinate, y coordinate going to be the same, I think this question will become easier. Okay, now how to find the point of intersection then? I think the best method would be that you take, let us say, for both the points, let me take them as x comma y. For point of intersection, let us call them as x comma y. For x, we will expect alpha and gamma to be there. For y, I will expect beta and delta to be there. Now, because x comma y lies on both the parabolas, its distance from the focus, that is x minus 4 square plus y minus 3 square, should be equal to distance from the directrices, which is x square in case of right opening, and it is equal to y square for the upward opening. Okay, now because I have already proved that x and y will be same, so you just need to put y is equal to x, and we get a quadratic, like x square plus 16 minus 8x plus x square plus 9 minus 6x is equal to x square. So this x square will get cancelled. We will be getting x square minus, I think, 14x plus 25 is equal to 0. Let me check if it is everything is correct or not. X square got cancelled. So minus 8 minus 6 minus 14x, and that is 25. That's right. Okay. And same quadratic will be for y coordinate also. And if we are looking for distance formula, distance actually between these two, it is nothing but alpha minus gamma square plus beta minus delta square, and that is equal to AB square. Because alpha is equal to beta and gamma is equal to delta, I think it is nothing but 2 times alpha minus gamma square. Alpha, gamma are the roots of this, so we will take the difference of roots, which is actually root d upon mod a, because it's a square, so d upon mod a, and d will be on 196 minus 4 AC, so 100. So this becomes 2 into 96. 2 into 96. So I think answer would be 2 into 96 is how much? 192. Yeah, 192. Answer was 192 for this question. Okay. In this question, I was trying with writing in the standard form, like y square is equal to 4ax with shifted 1 and x square is equal to 4ay with shifted 1. The calculation was so horrible, it cannot be done that way unless you identify that at the point of intersection, x coordinate, y coordinate will have same value. And that is, class, I will say this question is really very good question. Okay. Yeah, this question. Again, I will, I'll use characteristic equation, or without that also I can do this question. Please see how this kind of questions are done. We are looking for higher powers of 2 into 2 order matrix. This is 29th shift 1. So in this case, you can see this A has characteristic equation as a square minus trace, which is 2 into A, then plus the value of determinant, that is 1. Okay, so you can check, this comes out to be like A minus I square is equal to null matrix. You can do it directly also. A minus I will be 1 minus 1, 1 minus 1. And if you take the square, it will become equal to null matrix. But the idea comes from characteristic equation. Now, if A minus I whole square is 0, and let me write A as I plus A minus I. Okay, I has product with any matrix to be commutative. So in such cases, we can apply binomial theorem. When you apply binomial theorem, it will be I power n, which is nothing but I plus n times, or nc1 you can say, I power n minus 1 into a minus I ki power 1, and all higher power of a minus I will be null matrix because of this thing. So after that we need not to write. This relation we are getting as, this will be in, and this will be n into a plus, I think, 1 minus n into I, 1 minus n into I. Yeah. Okay, this will be valid for negative integers also, because this binomial theorem can be applied for negative integers also, which will go up to infinite. But in that case, this power 2, power 3, power 4, they all will be 0, 0, 0. So we can ignore same way as we have done it here. So this relation will be valid for negative integers as well as positive integers. So we will put this into that relation. A power m square will be how much from this relation? I think m square into a plus 1 minus m square into I. Okay, plus this a power m will be m into a plus 1 minus m into I. Okay, and this is equal to 3i minus, that is minus 6, so it will become minus minus plus 6a, and this will be, if you put n as minus 6, it will be 7 minus 7i here. Okay, now both sides you can check, we are getting m square plus m minus 6 into a, and on the right hand side this I is having m square plus m and 2i, that will be just 1i and minus, yeah, so minus 6 again here also. Okay, so both sides we are getting a and I getting multiplied with same quadratic. Okay, so that means we can say it is m square plus m minus 6 into a minus I is equal to null matrix. And because this is not null and this is a scalar quantity, m is integer, has to be scalar quantity, so that will be true only if m square plus m minus 6 is equal to 0. Now they are asking number of element in S. No need to solve it, although you can do it. In fact, you should do it actually. Why I'm saying this thing? Because we should check whether m is integer or not. I think it is integer. 2 and minus 3 are the roots. Okay, both are integer, and you can put it here and you can see m is equal to 2 and minus 3 will satisfy it. So your answer should be equal to 2 for this question. Okay, moving to the next question, 29th January, second shift, last shift actually. This was again one very good question, Bacho. Y square is equal to 12x is the parabola. S is its focus, PQ is the focal chord of the parabola, such that SP into SQ is 147/4. P is a circle, described PQ as the diameter. If equation of circle is this, then we have to find some alpha and beta. Okay, please understand PQ's focal chord. So P I can take as AT square comma 2AT. A is 3, AT square comma 2AT, 6T it will be. Okay, and for Q, because for focal chord other end has coordinate parameter to be minus 1/t, so it will be 3/t square comma minus 6/t. Okay, now SP, distance of P point from focus, is just A plus the x coordinate, so 3 plus 3t square, that is SP, and likewise SQ will be 3 plus the x coordinate, 3/t square, and that is equal to 147/4. You can take 9 common. Okay, it will be 1 plus t square into 1 plus 1/t square is equal to 3 will be cancelled. I think it will become 49/12. Okay, if you multiply it, we will be getting t square plus 1/t square, 1 plus 1, 2 also. So that will become 49/12 minus 2, that is 25/12. Okay, that is one equation I am writing. This is t square. Now we have to take same PQ as diameter, whose equation of circle is given like this. Now we will use diametric form. So x minus 3t square, x minus 3/t square plus y minus 6t, and y plus 6/t is equal to 0. Now if you open it, you get x square plus y square. For x, the coordinate, the coefficient will become minus 3 common, t square plus 1/t square into x. For y, it will become, I think, 6/t minus 6t into y, and the constant term from here it is 9, and from here it is minus 36, and that is equal to 0. Now to compare these two equations, okay, I think this alpha upon 64, if I divide this by 64, this alpha upon 64, there was minus sign also. Okay, so here also you can see there is a minus sign. It will be equal to 3 times t square plus 1 upon t square. I think we have found t square plus 1 upon t square here, that is 25 by 12. So this multiplication by 3 will give you 25 upon 4. From this we will get alpha to be equal to 16 into 25. I think this is 400. Okay, likewise we can find beta also. Let us do this calculation here. Okay, let us try to find the beta. Beta they have given on the other side. If you bring it this side, this will be minus beta upon 64, minus beta upon 64. But my constant are also with minus sign, so this will become equal to plus 27. Minus 9 minus 36 is minus 27, so plus 27. So beta will be equal to 64 into 27. Now we need to find beta minus alpha. That's it. Okay, beta minus alpha, if you do, it comes out to be 1328. You can see the kind of calculation they are expecting from you. Beta minus alpha will be equal to, it was 64 into 27 minus 400, actually 16 into 25. I think maybe you can do one thing, 27. How you will do it? You don't have calculator, take 16 common, so that will be 27 into 4, that is 108 minus 25. Maybe this way you can do it, 16 into 3 and 883, and then you can do the calculation. It comes out to 1328. See, even if you have done this question, this kind of number when coming, it doesn't give that much confidence in the exam. You have to be very fresh during the exam. You don't feel demotivated, no negative thoughts, then only you can feel confident while doing this question. So this paper, in that sense, for maths especially, I think 29 evening shift was difficult. Yeah, this is the last question for this session, I will say. This question also I found very good, actually. Again, this is a 1 power infinity form. You can see t approaching to 0, so this will become infinite. This is t here, and if t is 0, this will become 1, and 0 to 1 integration will be 1, so 1 power infinity in that sense. Now to find this, again same thing, t approaches to 0, we will write this as 0 to 1 3x plus 5 raised to the power t dt, because base is tending to 1, so I will subtract by 1 here, and this will be multiplied with 1 upon t, and this whole thing is raised to e. That is the question. Now after this limit t approaches to 0, now what we need to do, we can apply LH rule, L'Hopital rule, because that is 0 and that is also 0. Okay, so that we will do definitely, and we will get this to be actually equal to 0 to 1 inside integration, because my differentiation will be with respect to t, this integration is with respect to x. So inside this integration we can do this differentiation, and that will be 3x plus 5 raised to the power t log of 3x plus 5 to the base e dx. Differentiation of 1 will be 0 and differentiation of t will be 1. No need to write here. Okay, now it is not 0 upon 0 or infinity upon infinity form anymore, so we can put t is equal to 0 in the numerator, or let me not write t equal to 0 now. So this will become e raised to the power, this will become 1, t power t becomes 0, this will become 1. But by doing this L'Hopital, we need to do this integration. Okay, that is again a new thing to do here. What will this be? E raised to the power, try to understand, 1 into, you have to do by parts, or maybe you can use the formula of integration of log x. What is the formula of integration of log x? I think it is x log x minus x. This also you can use, or you can do by parts. Let us do by parts. So integration of 1 would be x, and this would be same 3x plus 5, and limit 0 to 1, then minus integration 0 to 1, integration of 1 will be x, and the differentiation of this would be 3 upon 3x plus 5 dx. Okay, here if I put the limits, it will be 1 and log 8, ln 8. For 0 it will be 0, minus, and everything is going in the power, and this here I will write it as 0 to 1 3x plus 5 minus 5, so it will be 1 minus 5 upon 3x plus 5 dx. 3x plus 5 minus 5. Okay, so here it will become e raised to the power log 8 minus, this will be just 1, minus minus plus I can write. Okay, integration of this would be, I think, 5 upon 3 log 3x plus 5. here also I need to put limit from 0 to 1. Yeah, happened. Yeah, we have to put the limit 0 to 1 here. So this is e power log 8 minus 1. For 1 it will be 8, for 0 it will be 3. So log 8 upon 3. This is what we are getting. Now let us remove this e from here. We could have done earlier also, but let us do it here. So this 8 will come here. E power minus 1 will give you 1 upon e, and here it will be into 5, 8 upon 3 whole raised to the power 5 upon 3. Okay. Now they are asking 8 upon 5 to the power 2 by 3. So if I write 2 by 3 here, so 1 8 by 3 will be released from here. 8 upon 3, 8 upon 3 is released. 8 upon e was already there. So this thing will be 8 upon 3 power 2 upon 3. Let us see if I am getting something similar to this or not. There was 5e, alpha upon 5e. Okay, if you put 0, this will be 5. I think this was 8 upon 5, not 8 upon 3. So 8 upon e into 8 upon 5, 8 upon 5 raised to the power 2 upon 3. So if you compare both of them, your e should be 64. Yeah, your e should be, not e, alpha should be 64. Comparing, you will get alpha to be equal to 64. So these are the questions for this session, bachcho.